Okay, in this screencast I want to talk about conditional probability and talk about what that means. So what we're doing here is placing certain conditions on on an event. So rather than just saying, here you go, roll a die, select from this group of people, we're sort of going to say, no, well, you can select from this group of people, but they must be male, or the die is, we know that the outcome is, in this example we'll see in a minute, we know it's an odd number. So there's a condition that's placed on the probability, and the effect is that the sample space is changed. That's the important thing. Alright, so just have a little read through here. Conditional probability changes the sample space in an experiment. So simple example, I've just rolled a little die here, we've got 5 on the top. I'll find the probability of rolling a die. If we just rolled that die, place no condition on it, then the sample space is 6. It could be any one of the 6 faces. So 5, rolling a 5 is 1/6 the probability. But if we say now, given that the die shows an odd number, so we're saying, no, we know that it's an odd number, i.e. 1, 3, or 5, find the probability of rolling a 5. So importantly, just here, I want to highlight this, what I've written here. This says the probability of a 5 given that. This, when you ever see this line here, that means given that this is a condition. It is odd. We know it's odd. So now the probability of rolling a 5, the sample space has changed. It's now 3, because we can only have 1, 3, or 5. So the probability of a 5, given that the number rolled is odd, is 1 in 3. Okay. Moving on. So finding conditional probabilities using a Venn diagram firstly. So here's a Venn diagram. We've got, this is set A here, and this is set B. And so we need to find the probability of A. These are the numbers in each set. So there's 3 in A, 4 in B, and 2 in both. Nothing outside. So there's there are 9 elements total. So the sample space is 9. So the probability of an A is 3 plus 2, 5 over 9. Now the probability of A intersection B is just that in there. So that's 2 out of the 9, the sample space of 9. Now, probability of A given B. So now the sample space is going to change. We know that it's that B, we're selecting from B basically. So what's the probability that it's also A given that we're selecting from B? So our sample space is now what I'm circling, just that there, the 2 and the 4. So my sample space is now not 9, it's 6, and of that 6, A represents 2 of them. So it's 2/6 or 1/3. That was a bit messy. 1/3. And in the last question, probability that it's B, given that it's A. So again, the sample space now has changed. It's now changed to that there, 5. 3 plus 2. Of that 5, the B represents 2 of them. So 2/5 is our probability there. So there's conditional probability in a Venn diagram. We're going to look at it in a two-way table now. From a group of 15 hockey players at a game of hockey, 13 played on the field, 7 sat on the bench, 5 both played and sat on the bench. So A is a person on the field. What I'm going to do here is I'm going to put this in a Venn diagram first, and then have a look at how it looks in a two-way table. So it's in a Venn diagram. This is how to do our Venn diagrams. Look at the information. 15 hockey players, 13 played on the field, 7 sat on the bench, and 5 played. Without that, we didn't even need this information. Add the 13 and the 7, that's 20. I've only got 15 players, so the difference between 20 and 15 has to go in the middle. 5 both played and sat on the bench. I knew that. Now once I've got that, I've got 13 played on the field. That's A. So I've got 13. So this number, so I've got to put a number here, so that this number and this number add up to 13. Okay, if I put 13 there, then that's 18. That's not what I want. So I've got to work from the inside out. 5 plus 8, 13. 5 plus 2 is 7. B represents person sat on the bench. So 2 goes in there. 8 there. We've got none out here. 8, 13, 15. We've got no players that do neither. So in a two-way table, how would that look? Well, we'd have our A and A complement. We'd have our B and B complement. And we draw it up like so. And our A intersection B would be, put 5 in there. Our A intersection, our A complement B complement, not A, not B, that's 0. Our B but not A, so in B but not A, so that's that 2. and in A but not B, and in A but not B, that's 8. So if we add up through here, we get 7 and 8, we get 13 and 2, and we get our magic number 15, which is the sum. So there it is in a two-way table. We can find a few probabilities now. So the probability of B given, sorry, B intersection not A. So this is saying this is the probability that the person only sat on the bench. So sat on the bench, which is B, didn't play at all. So sat on the bench, so B, and did not play. There we go. So that's 2. That's 2 out of, so it sat on, so, yep, so sorry, that's 2 out of 15. Just jabbering on a little bit there. Let's have a look at another probability now. Probability of, let's use one of these conditional probabilities, B given A. Okay, so what's the probability that the person sat on the bench given that they played on the field? So probability of B given that A happened. So here's my A column. Okay, so I've got 5 plus A, I've got 13 in my column. That is now my sample space, 13, not 15, 13, because I'm told that A happens. If you'll ever look at the Venn diagram, it's that, it's 8 plus 5. So my denominator is 13. How many of that 13 is B? I can see it's 5 there, I can see it's 5 there. So 5/13. And finally, probability that it's A given B. So this is the other way around, the probability that the person played on the field, A, given that they sat on the bench. So we're now given B, so we're in this here. So it's from the 7. It's from the 7 here, from the 7. How many of those are A's? 5 of them are A's. So 5 out of 7 is my probability there. Conditional probability. Hopefully that made sense, and we can clarify any misunderstandings tomorrow in class, but make sure we come ready to work. I'll see you soon.